Hey, party people. We are going to finish up with Power Series today. I've got a couple bits of unfinished business for us to take a look at. A reminder from, I guess I want to call it yesterday, but I suppose the previous day. You probably watched this video on Tuesday. We looked at for a Power Series that's in this form, uh, the sum of something times x minus some value that is the center of our interval of convergence to the n power. Usually it's just in the form of x to the n power, but if it's x minus something, that moves the center of convergence to whatever that value is. The series either converges at only that point because everything is equal to 0, it converges everywhere, or the most interesting one that we're going to take a look at more closely today is if there is a radius of convergence and anything within that radius um, it does converge for. When last we were together, we were filling out a few of these. I believe we left off at this one. I didn't do this one, but I left it for you to do. If you send this series through the ratio test, you should find that it converges for all values of x. So for all real numbers, which means we have an interval of convergence from negative infinity to infinity. I suggested that you take a look at this next one. If you haven't had a chance to take a look at it, pause the video right now, take a look at it, try it out with the ratio test to figure out what the interval is. And if you paused, you're back with us at this point, and I'm going to take a look at how we do this one. Again, I've just scanned my process. You don't have to put up with me trying to write this out in front of you. Here's the interval, or excuse me, the series that we're looking at. Sending this through the ratio test looks similar to what we've seen before. Limit as n goes to infinity of the absolute value of the n plus first term divided by the nth term, or in this case, times the reciprocal of the nth term. I've grouped the -3 to the power terms, the x to the power terms, the radical terms together so I can see how they cancel out. I've got one more on the top than the bottom. I've got one more x on the top than the bottom. And then I can combine these two radicals together to make one big radical. So we end up with -3x. This radical, as n goes to infinity, this term just goes to 1. The larger the value of n, the less the +1 and +2 matter. And so this ends up looking like 1. And so I've got, I guess I don't even need the limit notation here anymore. I've got the absolute value of -3x. And the absolute value means I don't care about the negative. In order for the ratio test to show us that it converges, this ratio must be less than 1. So if the value of x is between -1/3 and +1/3, that keeps the value of this less than 1. The big question is, what about at those points? I've got a radius of convergence of 1/3. Everywhere between -1/3 and 1/3, this series does converge. But at those values, we need to take a look at what is this interval? Does it include these endpoints? And so to do that, I'm just going to plug them in. I plug in x equals -1/3 to the series, replace the x with a -1/3, and see what happens. And now this looks like problems, well, gosh, problems that could be on your quiz on Friday. This series, if I've got this thing to the n times that thing to the n, I can combine those together. -3 times -1/3 is just +1. And so no matter the value of n, the numerator is equal to 1. And I've got the sum of 1 over the square root of n plus 1, which feels a lot like a p-series. It's not quite a p-series. It's a little bit less than a p-series. So I can't just do a straightforward comparison, but I can do a limit comparison test and show that that um, the p-series that I'm comparing it with diverges, which means this one is going to diverge as well. So this series diverges at x equals -1/3, but then at +1/3, when I plug in +1/3, -3 times a third is a -1. I've got -1 to the n. And all of a sudden, this series, instead of looking like a p-series, this is an alternating series. And since the terms are going closer and closer to 0, that means that it converges at that value, which means my answer, my interval of convergence, is between -1/3 and +1/3, including +1/3, but excluding -1/3. And so we've got this unique case where even though the radius of convergence is 1/3, and I'll go back to this table so we can finish filling this out. The radius is 1/3, but my interval includes one endpoint, but not the other. It does not converge at -1/3, but it does converge at +1/3. And so this is the trickiest type. And if this was a normal year, I would guarantee that something like this is going to show up on the AP test. I'm not so sure this year because of the shortened test that you guys are going to be taking, but I would still definitely have that as something that you would watch out for. Moving along, I just want to take a look at a couple of the questions that are relevant to this that are in the assignment. Questions numbers 29 and 30. I don't think these are very obvious what the process is supposed to be, so I'm going to take a look at these quickly with you just to make sure that you know what the idea is. In number 29, we're given that the series something times 4 to the n is convergent, and they want to know if we can logically conclude from that that either one of these two series would be convergent as well. And so what I take from this is we've got our general form of a power series, the sum of something times x to the n. And it could be x minus something to the n, but in this case, I've just got 4, so I'm going to treat this as plugging 4 in. If I plug 4 into this series, it converges. And so that tells me I'm going to draw a number line here to help illustrate this idea. The center of convergence is 0 because it's just x to the n. It's not x minus 5 to the n or anything like that. It's just x to the n. And I know that it converges at x equals 4, which tells me that my radius of convergence is at least 4. Maybe it's infinitely big. Maybe this converges for all real numbers and we only know about the specific value of 4, but I know that it converges at 4. What that tells me is that my radius must be at least 4. So for any value between -4 and 4, I know that this is going to converge. I know that for any value I plug in here between -4 and 4, this will be a convergent series, including -2. -2 is on that interval of convergence, so we can conclude that it will converge at -2. My answer is that yes, I can conclude that for part A. Part B, on the other hand, I don't know. I can fill in the circle on this one because they told me that it converges at x equals 4, but I do not know about this. And we just saw an example between -1/3 and +1/3. It is possible that it converges on one side, but does not converge on the other. So I cannot conclude that it converges at -4. It might, but it certainly might not. And this idea is going to be used on question number 30 as well. I'm going to give you a chance to pause here again. Take a look at this question. Think about it in terms of what we just saw. Pause. And if you paused, we're back. And if you didn't pause, we're still back. And so what I would do for something like this is to say, same format, something times x to the n power. So my center is at 0. And I'm told that this series does converge at x equals -4. So at x equals -4, it does converge, which means it must converge for every other number within 4 of 0. So I know it's going to converge all the way out to 4, possibly at 4, possibly not at 4. I'm not sure about that. But then we're also told that it diverges at x equals 6. And so what that tells me is that everywhere in here, it must converge. And let's see, it diverges when x is equal to 6. So everywhere out here, it's going to diverge, which also means if I'm back here at -6, I'm not sure about the behavior at that point, but I know that since it diverges at x equals 6, the radius of conversion can be no more than 6, which means everything over in that direction is going to diverge for also. This region right here is a big fat question mark. I don't know what's happening between 4 and 6. I know that in between -4 and +4, it must converge. I know anything farther away than 6, it must diverge. Question mark on the rest of it. So in answering the questions, part A, we've got C sub n, the coefficient. And since there's nothing there, I guess it's just 1 to the n power. X is equal to 1. 1 is within my interval of convergence, and so it must, I guess I shouldn't be circling that. I know that it is convergent for part A. Part B, I'm plugging in 8 for the value of x. 8 is farther away than 6 is, and so we can state conclusively that this must diverge for x equals 8. Part C, we've got x equals -3. -3 is within that interval of convergence, so I know that it must converge there. And finally, they get a little bit tricky with this by putting this -1 to the n. Usually when I see that -1 to the n, I think alternating series. And this one could be an alternating series, but I also don't know. C sub n, the coefficients that we don't know about, those could be alternating, and this -1 to the n may just be offsetting. There's too much that I don't know here, but I do know that it diverges when x equals 6. It's going to diverge when x equals 9 as well, because 9 is farther away from my center 0 than 6 is. And so that's how we're doing this. If they had put 5s in here or 4.8s, I wouldn't be able to draw any conclusion. I wouldn't know what the answer to that question is. And so that's the idea on those problems. This video is a little bit shorter than the ones that I made for you earlier in the week. Hopefully you had a little bit of time yesterday to digest those videos and go through those example problems. You guys do have a quiz tomorrow on convergence of series, sections 11.1 through 11.7, all the sections that we did before break. I would like to give you guys the opportunity to ask me some questions later today. I'm going to be publishing this video on Thursday. So on Thursday, the day before the quiz, when you're probably watching this video, I'm going to try out, I haven't done this yet, but I'd like to try out the Schoology Classroom, or the Schoology Conference, I guess it's called. I'm not sure exactly how this works, but I'd like to try to do something at 2 o'clock. If that's an absolute failure, I have been using Zoom for some stuff, so we'll use Zoom as a backup plan, but I'd like to try the Schoology Conference around 2 o'clock. So show up on Schoology at 2 o'clock. You'll be able to ask questions, get questions answered, maybe help answer questions, or maybe just complain to me about how boring my videos are, or whatever you would like to talk about at 2 o'clock. If no one shows up by 2:15, I will probably not hang around longer than that, but I will definitely be there from 2 o'clock until 2:15, and I will keep answering questions as long as you guys have questions. If we're going until 3 o'clock, that's great. If we're going until 5 o'clock, we can make that work too. So hopefully I see some of you virtually online at 2 o'clock later today. Otherwise, good luck in preparing for the quiz. The quiz will be published tomorrow. I'll put more information on Schoology so you know what to do, where to look for that. As always, check in with questions on Google Hangouts, or send me an email, or communicate on Schoology, or send up smoke signals. I'll be watching for those also out my window. So I'll see you guys virtually tomorrow. Peace out, Home Slice.